In this video, we will cover some of the basic switching concepts. Let's start with a hub device. A hub is a common connection point for devices in a network, and those devices commonly used to connect segments of a local area network. The hub contains multiple ports, and when a packet arrives at one port, it is copied to the other ports so that all segments of the local area network can see all packets. So in a hub, a frame is passed along or broadcast to every one of its ports. So it doesn't matter that the frame is only destined for one port. The hub has no way of distinguishing which port a frame should be sent to. So passing it along to every port for hub ensures that it will reach its intended destination. So guys, in today's modern networks, we are not really using the hubs because the information comes from one port, is flooded to all other ports, and it is a very inefficient use of the bandwidth. On the other hand, what we are using instead of hubs, we are using the switches. Okay, a network switch, that is a device that connects devices together on a computer network to receive, process, and forward data to the destination device. So a network switch uses the MAC addresses to process and forward data at the data link layer, which is layer 2 of the OSI model. So some switches can also process data at network layer, which is layer 3 of the OSI model, and those switches are known as multi-layer switches, and they are capable of routing as well. Let's go ahead with the broadcast domain terms. A broadcast domain, that is a logical division of a computer network in which all nodes can reach each other by broadcast at the data link layer. So a broadcast domain can be within the same local area network segment, or it can be bridged to other local area network segments. So any computer connected to the same switch is a member of the same broadcast domain. Further, any computer connected to the same set of interconnected switches is a member of the same broadcast domain as well. So the routers and other higher layer devices form boundaries between broadcast domains. Also, creating VLANs, separating the VLANs divides the broadcast domains as well. So let's have a look to the example on the screen that you are seeing. In this example, I have my router 1, okay, and it is connected to this segment from this interface, this segment from this interface, and this segment from this interface. Okay, each router interface is a boundary for a broadcast domain. Okay, so that is why in this screen I am seeing 3 different broadcast domains. Okay, no matter in this segment I have a switch or not, as you can see in here, unless there is a router in that particular segment, there will be no additional broadcast domain. So even if I would have multiple switches, for example in here, or another switch connected to here, no problem. Okay, they won't form any boundary for the broadcast. There would still be 3 different broadcast domains in this topology. So let's continue with the MAC address. A MAC address is a 6-byte unique identifier, that is the important part, assigned to network interfaces for communications at the data link layer, which is the layer 2 of the OSI model. The MAC addresses are used as a network address for most IEEE 802 network technologies, including the Ethernet and the Wi-Fi. Okay, so logically MAC addresses are used in the Media Access Control Protocol sublayer of the OSI reference model. So MAC address has mainly two different portions, OUI and the UAA. Each portion is 3 bytes, okay? First of all, an OUI is a 24-bit 3 bytes number that uniquely identifies a vendor, manufacturer, or other organization. These are purchased from the IEEE and they are used as the first portion of derivative identifiers to uniquely identify a particular piece of equipment as MAC addresses. The other portion of the MAC address is universally administered address, okay, UAA, and this one is uniquely assigned to a device by its manufacturer, okay? So the vendor is the one who is assigning the UAA. The IEEE is the one who is assigning the OUI to the vendors. So let's continue with the Ethernet frame. As you are seeing on the screen, Ethernet frame has multiple fields. The first field you are seeing on the left is preamble, which is 7 bytes and communicates to the receiving devices whether a frame is coming and provides synchronization. We have start of frame delimiter SFD, which is 1 byte and responsible for specifying the beginning of the destination MAC addresses in next byte. We have destination and source MAC addresses, which defines the requested receiver of the frame and the sender of the frame. We have VLAN tag, which is optional, guys, and carries VLAN information if any VLAN configuration is there. We have type field, which defines the protocol type that is listed in the frame. We have data, which carries the data information that comes from the upper layer, okay? We have pad, which the sender adds to ensure the minimum payload length. And we have the frame check sequence that is 4 byte and detects if there is a transportation error on the frame or not. So lastly, let's talk about how a basic switching process works. Okay, so as you know, switches forward frames based on their MAC addresses, and those MAC addresses are found in the CAM table. Okay, so if the destination MAC address is found in the CAM table, the switch sends the frame out of the corresponding port on. Okay, so this process is called forwarding. If the destination MAC address cannot be found in the CAM table, the frame is sent to all other ports in the same VLAN. That is very important, keep in mind, guys. So this is called flooding. And lastly, if the destination MAC address of the receiving frame is the broadcast MAC address, which is FFFF, FFFF, and FFFF, the frame is again sent to all ports in the same VLAN, and this process is called also flooding. Alright guys, we are coming to end of this section. Thank you so much for joining me.